Okay, so the first question is the difference between place values of 7 and 3 in the number 527,435. Okay, that is 5,27,435. So first of all, see the place value of 7. So which is the place value of 7? If you see this is the 7 located. So if you have all the zeros after 7, so the place value becomes 7,000 because there are three digits ahead of 7. So we'll have to fix three zeros after 7. So the number is 7,000 and 3. So let us see where is the 3 located. 3 is located here. And how many digits are after 3? So there are two digits. So we can write the number as 30. Okay, so the place value of 7 is 7,000 and place value of 3 is 30. He's asking for what is the difference between place value of 7 and 3. So we need to subtract these two numbers, 7,000 minus 30. That is going to be 6970. That is the right answer, which is available in option number C. Okay, so the next question is find the sum of two numbers whose bigger number is greater than the smaller number by 1. That is the difference between the bigger and the smaller one is 1. And the square of the bigger number is greater than the square of the smaller number by 9. So this is the situation given. So we'll have to assume some variables as bigger and the smaller one. Then we'll make some equations out of them. And then we'll try to solve those equations for getting both the numbers. So basically he's not asking for both the numbers. He's asking for find the sum of the two numbers. So let us assume something. Okay, let us assume the greater number. Let's say the greater number is x. Okay, similarly, let us assume the smaller number. Let us assume the smaller number to be y. So the greater number is x and the smaller number is y. Now the first condition that he says is bigger number is greater than the smaller number by 1. So that means difference between the bigger and the smaller is 1. This is the first equation that we have. And then he said the square of the bigger number. So let us do the square, that is x square is greater than the square of the smaller number. So difference of the square of the first number and the square of the second number, he says, is how much greater? The greater by 9. So it's equal to 9. So this is going to be the second equation. So we need to solve these two equations to get the x plus y value. So we can see this x square minus y square. We know a square minus b square is nothing but a plus b multiplied by a minus b. We already know this, so we're going to use this. So x square minus y square can be written as x plus y into x minus y is equal to 9, where x minus y is equal to 1. We already know, we already established in equation number 1. So we can put this value of x minus y equal to 1 in the new equation that we have formed, this one. So if we do that, x plus y is as it is, x minus y value is 1 from the equation number 1 is equal to 9. If we solve this further, what does this gives us? This gives us x plus y value equal to 9. And what they has asked in the question, they had asked find the sum of two numbers. So clearly the sum of two number becomes what? X plus y equal to 9. So the sum of two number is nothing but 9, which is available in option number B and is the right answer. Okay, find the total number of odd numbers up to 419. Okay, total number of odd numbers up to 419. There is a simple formula for this. Odd number up to certain numbers. So see, we have to find out total number of odd numbers up to 419. 419 itself is an odd number. So the formula says you have to add 1 to the odd number, divide that sum by 2, where n is nothing but the odd number that has been already given. So if we put the 419 value into the 9 into the n, we're going to get to as 419 plus 1 divided by 2, which is nothing but 420 divided by 2, and which gives us 210. So the total number of odd numbers till 419 are 210, 210 available in option number A and becomes the right answer. Now, there's a mathematical expression given 2 minus 1 by 3, 2 minus 3 by 5, 2 minus 5 by 7, dot dot dot. This series continues till 2 minus 997 by 999, and we have to find out the value of this particular expression. So let us try to solve these numbers. So first is 2 minus 1 by 3. If you solve this, so this is going to be 3 to just 6 minus 1, that is 5 by 3. Okay, if you solve the other bracket, so that is going to be 2 minus 3 by 5. If you take the LCM as 5, it's going to be 5 to the 10 minus 3, that is 7 by 5. If you solve the third one, you will have to do it, the LCM being 7. So 7 into 2, 14 minus 5 is 9 by 7. And this is how it will continue. And the last value that is given is 2 minus 997 divided by 999. Obviously, LCM is going to be 999. Then 999 into 2 we'll have to do. We'll have to do 999 into 2. That is going to be 1098. 1098 minus 997 will be 1001. So this is going to be the complete left hand side. See the pattern here. So obviously this 5 and 5 will get cancelled. This 7 and this 7 will get cancelled. So in this way, all these numerator will be cancelled out with their corresponding next terms denominators. So ultimately you are left out with this very first denominator and the last numerator. You will be ultimately left out with the first denominator because that will not be cancelled out with anything, and the last numerator because that will also not be cancelled out with anything. So the ultimate value that you're going to reach to is 1001 divided by. So this is going to be the ultimate answer of this particular series. It is available in option number D and becomes the right answer for us. Next, what should be the maximum value B in the following equation? Okay, so let's just write this particular equation. Let us try to write the left hand side first. It's going to be 5A9, then it is subtracting 7B2, then it is adding 9C6. Okay, so this is a cryptographic based question where there are some letters and some numbers and they are being used up into the mathematical operative form. So we can clearly write that second number is to be subtracted, okay, and the third number is to be added up, and this is how we have to see it. Okay, if you try to solve this, okay, so clearly we have to subtract. Let us begin with the first row, that is the unit place of all the things. Okay, so if we try to add and subtract like that, so it's going to be 9 minus 2, that is 7. 7 plus 6, that is going to be 13. So clearly 3 will come down here. 9 minus 2 is 7. 7 plus 6 is 13. So 3 will come down here. So there will be a carry generated. That carry is going to be 1. Let us write that carry here 1. Now in the 10th place, what we are doing? So clearly 1 plus A minus B plus C. This is how it will happen. So what will come in place of this is 1 plus A minus B plus C. Okay, that will come 1 plus A minus B plus C, and the result is already written out to be 823. Result is already given in the expression. The right hand side is already given as 823. So we can use that result also, 823. So ultimately the value should come here as something ending in 2. Now we need to see this, that this has to be something ending in 2, and clearly we are adding up all these numbers. So this value has to be not just 2, but this has to be at least 12. So let us assume this to be as 12. Now again the carry 1 will be generated. So this is that carry that will be generated from the 10th place. Now what is happening in the 100th place? See, 1 plus 5, 6 minus 7 minus 1 plus 9. So it's going to be 8. So what is happening is 1 plus 5 minus 7 plus 9. It is going to be 8. So it is completely verifying it. So our assumption that unit place, that 10th place of the number resulted in the second 10th place was 1 is right, because we have used 1 here and the equation has been balanced. So this is what is going to be. So the ultimate equation that we have to solve using all this is A minus B plus C is going to be 1 minus A minus B plus C is going to be 12. So it gives us A minus B plus C is going to be A minus B. This was plus A minus B plus C is going to be 11. So we have to use this. A minus B plus C is going to be 11, and we have to find out the maximum value of B. So clearly, if you use the options given in the question itself, okay, what should be coming as the maximum value of B? So if you take as 5, so A minus A plus C, if you use the first option 5, then A plus C will be going to be 11 plus 5, 16, which is quite possible because 16 can be made easily by any two-digit number combination. Then, so 5 can be one of the answer, but this is not the maximum answer. If you use 6, then A plus C is going to be 11 plus 6, that is 17. 17 can also be resulted at a sum as a sum of two single digit numbers. So 6 is also possible. If we go for 7, so A plus C will be going to be 11 plus 7, that is 18. 18 is again possible by two single number digit addition, that is 9 plus 9. So 7 is also possible. Let us check for 9. If you check for 9, then A plus C is going to be 11 plus 9, that is 20. Now 20 cannot be a result of the addition of the two single digit numbers. So that means 9 cannot be the option for B. So the maximum option that can be available for B is going to be 7. So the right answer becomes 7. That is option number B. Okay, so the question says a boy multiplies 987 by a certain number and obtains 559981 as his answer. Okay, if in the answer both nines are wrong, that means the first nine and the second nine are wrong, but the other digits are correct, then the correct answer will be okay. So ultimately there is a number, let's say that number is x, that has to get multiplied by 987 and should give a result. Okay, in this result two nines are wrong, so let us not focus on this number, let us focus on the options. Out of all these options, a, b, c or d, any of the options should be right and that should give the answer here. So how we are supposed to do it? Okay, so we are just supposed to see 987 first, because we are about to find this particular number. Okay, so whatever this number is, so x value should be this number, that is available options a, b, c or d divided by 987. Okay, so we have to find out the factors of 987, because it is very difficult to divide these numbers. Look at the first number. The first number, first option is 556581, and if we try to divide it by 987, it is going to be very difficult. So what we cannot do, we'll not completely divide it by 987, rather we'll break the factors of 987. So if we do the factors of 987, the 987 can be divisible by 3, and this should give me 3 3 ja 9, 3 9 ja 81, 3 3 2 ja 6, and 2 3 9 ja 27. Then we can divide it by not 3 not 5, we can divide it by 7. If we divide it by 7, this is going to be 4 28, and 4 7 7 is 49, so 47 is a prime number. So the factors of 987 are 3 7 and 47. So ultimately I have to divide this number. The first option is 556581, it has to get divided by 3 and 7 and 47, it has to get divided by 3 7 and 47. Okay, so just look at the options, okay, and just see which particular option is that which is completely getting divisible by all these numbers 3 7 and 47. Okay, so let us see the first option. Okay, the first option is divisible by 3 and 47, but is not divisible by 7, not by 7. You have to divide it and then check. The first option is not divided by 7, so it cannot be the right answer. If you see the option number C, this option number C is being divided by 7 and 47, but this is not getting divided by 3. So it is not getting divided by 3, this option, so it cannot be the right answer. Similar goes for the option number D. This is also not divisible by 3. So obviously the right choice is option B, 555681, because it is completely divisible by 3 also, divisible by 7 also, and divisible by our 47 also. So that should be the right answer. 555681, option B is the right one. Okay, the smallest value of n for which 2n plus 1 is not a prime number is, so what we can do, we can put the options and then we can check one by one. So if we put 5 as an option in the 2n plus 1, it's going to be 2 into 5 plus 1, that is 11, but 11 is a prime number, so A cannot be the right answer. What about B? If we put n as 4, it is going to be 2 into 4 plus 1, that is nothing but 9, but 9 is not a prime number, so the 4 becomes the right answer, because 9 is not a prime number. That's what they had asked. For what value of n the n is not going to be the prime number, but he has also asked for smallest, so we have to check other option also. Let us check the other option, that is 3. So if we multiply 2 into 3 plus 1, this is going to be 7, and 7 is a prime number, so this cannot suit our criteria. Let us see the last one, that is 2. 2 into 2 4 plus 1 5. 5 is a prime number, so again this doesn't suit our criteria. We require something that is not a prime number, so that is only being possible for the option called as B, so that is going to be the right answer. Okay, 3,25,325 is a 6-digit number. It is divisible by which? Okay, which of these number are completely dividing this number? So this question can be easily done by dividing these numbers by, because see the number 3, 3,25,325 is not going to be a very huge number. So we can quickly check them by dividing first by 13, then by dividing by 11, then by dividing by 7. Okay, so we checked it one by one, and then we are coming to the conclusion that this particular number is completely getting divisible by all three: 13, 11, 7, all three. So that's what was available in option number D, that it is divisible by all of these numbers. So that is the right answer, option number D. Now, the sum of digits of a two-digit number is 9. If the digits are reversed, then their difference is also 9. Find the number. So in this case, in these type of question, what we do, we assume the digits. Okay, we assume the unit digit, we assume the 10 digit, and then we try to frame the condition as per it. Then we try to make the number. Okay, so let us do that. Let us assume a digit. Let us assume the unit digit. Okay, let us assume the unit digit. Let us say the unit digit is going to be x. Okay, now there is a condition that given sum of digits of two-digit number is 9. So sum of the unit digit plus sum of the 10 digit, we can say like that: sum of unit digit plus sum of 10th digit. 10 digit is going to be 9. So clearly the 10 digit is what? 10 digit is nothing but 9 minus x. Okay, unit digit is x and 10 digit is 9 minus x. This is what we can understand. Now, how to make the number out of it? See, the number is always going to be, okay, the number is always going to be 10 times the 10th digit, 10 times the 10th digit plus unit digit. This is how the number is formed: 10 times the 10 digit plus the unit digit. So let us make it 10 times the 10 digit. For our case was 9, so it has to be sorry, 10 digit for our case was 9 minus x, so it has to be 10 into 9 minus x plus unit digit is x. So this is what we can, this is how we can make our number. So number is coming out to be 10 into 9, 90 minus 10x. It is going to be 90 minus 10x plus x, which becomes 90 minus 9x. This is what is the number becomes. Okay, now in the next case he say if the digits are reversed, so let us do the reversal. Okay, if the digits are reversed, then we can say the 10th digit is what? The 10th digit is going to be x now, and unit digit is going to be what? As they say, unit digit is going to be 9 minus x. So the numbers are, the digits are reversed. Now how can we make the number? So let us make the number 2, or the reverse number. How can we make the reverse number? Again the formula is same: 10 times the 10th digit plus the unit digit. So if we try to make it this way, 10 times the 10 digit is going to be 10x this time, plus the unit digit, that is 9 minus x. For this case, this is going to be 10 minus x, that is 9, that is going to be 9x plus 9. This is going to be the reversed number. What he has said further, if the digits are divided, then their difference is also 9. That means difference of the original number and the difference of the reverse number is 9. So if you try to do the difference, okay, so he says difference of the original number, that is 90 minus 9x, minus the reverse number, that is 9x minus 9. He says the answer is again 9. So we are just not supposed to solve this to get the x value. If we solve this, 90 minus 9 is 81, and 81 minus 18x is going to be 9. So clearly 18x is going to be 81x plus 9, that is 90. So the x value should come out to be at a unit place, okay, 81x plus 9, rather it has to be 81 minus 9, that is going to be 72. So x value should come out as 72 by 18, that is nothing but 4. That's what is x coming. He had asked for what, find the number. So the original number is this 90 minus 9x, that is the original number. So if we put x equal to 4 in this particular expression, 90 minus 9x, it is going to be 90 minus 9 into 4, that is 90 minus 36, and which is going to be 54. So that's what is going to be our answer. 54 is the number. So that is available in option number B and becomes the right answer for us. Now, if the sequence 17 dash 18, 15, 19, 14, 20, and 13, find the missing number. Okay, so you just quickly have to look at this and try to do set up some logic into it. Okay, if you look at the numbers, what is it going to be? 17, then there is a drop of a number, it becomes 18, then there's a drop of a number, it becomes 19, then there's a drop of a number, then it becomes 20, and so on. And on the other side, if you see, 13 with a drop of a number is 14, with a drop of a number is 15. So if you see the number starting from 13 towards the left side, they are being increased by plus 1. Okay, it's becoming 13, then plus 1 is 14, then there is a gap, and there is a gap, 14 plus 1 is becoming 15. So after the next gap you should receive here as 16. So the number that should come here at this place, at the gap place, is nothing but going to be 16, which is available in option number D, and becomes the right answer for us. Option number D, 16 is the right answer. Now, how many numbers up to 4 digits are divisible by 13? Okay, how many numbers up to 4 digits are divisible by 13? In this situation, what we can do, we'll try to make the maximum 4-digit number. Okay, and biggest 4-digit number is nothing but 9999. That is 9999. Okay, this is going to be the biggest 4-digit number. And he says how many numbers out of these till this number are. So we have to suppose to find out how many numbers from 0 to 9999 are divisible by, to find out this, are divisible by 13. So every number that is divisible by 13 has to come after a drop of 13 numbers only. For example, 13, then 26, then 39, then 45. This is how the multiples of 13 will be there, because 13 is a prime number, so there won't be any number in between the gap of 13 numbers. So clearly those numbers which are divisible by 13 from 0 to 999, 4 times 9 is going, can be found out by dividing this by 13. Okay, if you divide this by 13, it can be completely divisible by 769. So clearly 769 numbers will be there which will be completely divisible by 13 from 0 to 9999. So that is going to be the answer, option number A, 769. How many numbers up to 493 are divisible by 17? Okay, up to 493 are divisible by 17. Again, it is going to be the same situation. 17 is going to be a prime number. So the multiples of 17 will come in a drop of 17, 17, 17, 17 always. For example, the number that is going to be 17, then the next number divisible by 17 will be 17 2 ja, then there will be 17 3 ja, then there will be 17 4 ja, then there will be 17 5 ja, and so on. So they will be falling in the drop of 17, 17, 17 only. So clearly how many numbers are there from up to 493 that are divisible by 17 can be found out by dividing the number by 17, and if you divide this you are getting the answer as 29. So there are 29 such numbers which are divisible by 17. So that is the right answer, option number C. Of the three numbers, the first is twice the second and thrice the third. So in this type of situations, we have to assume a single number, okay, a single variable, and uh, taking the reference of that single number, we can make the other two numbers. So let us try to establish that which particular number can be assumed so that the other two numbers are easy to name. Okay, look at that. First is twice the second and thrice the third. The first number is twice the second and thrice the third. So we can begin with anything otherwise. Okay, so let us assume the third number itself. Okay, so let us say the third number is, let us say we are assuming, let third number is x. So if the third number is x, he says uh, first is first number is thrice the third. So the first number will be what? If the third number is x, so first number will be thrice the third, that is going to be 3x. Then he has said first is twice the second. So first is also twice the second number. Okay. First is also twice the second number. That means second number will be half of first. So we can write down second number is half of the first, and the first is 3x itself. So it's going to be 3x by 2. So these are our numbers. First is 3x, second is 3x by 2, and third is x. We have assumed our numbers. Then look at the condition. The condition that is given is if the average of 3 is 22. What is an average? Average of any numbers are nothing but sum of those numbers divided by total number of those numbers. Okay, this is the basic formula. So he says average is 22, so that is 22. That can be found out by adding all of them, sum. So that is going to be x plus 3x plus 3x by 2, and dividing them by 3 because they are in 3 in number. So we just need to solve this particular equation. Okay, if you solve this is going to be 11x by, okay, this is going to be 11x by 2. Okay, and this is going to be into 1 by 3. Okay, so we can simply solve it. So 11x by 6 is going to be 22 if you solve this further. Okay, 11x is the rather x is going to be 12. So we have got the x as the number. He says find the three numbers. So first number, the third number is going to be 12 because it was x. Okay, we can say the third number is going to be 12. What is going to be the first number? Thrice of third. So first number is going to be thrice of 12, that is 36. Second number is going to be 3x by 2, that is half of first. So the second number is nothing but 36 by 2, that is 18. So these are the numbers 36, 18 and 12. So this is available in option number C, 36. Rather, this is available in option number D, 36, 18 and 12. We have to take care of the order also. The right answer is option number D. Which of the following numbers is exactly divisible by all prime numbers between 1 and 17? Okay, we are supposed to find out which of these numbers is divisible by all the prime numbers between 1 and 17. So, for these type of situation, we are not supposed to divide each and every number by all the prime numbers that are between 1 and 17. Rather, we'll try to have some guess around it. Okay, let us try to see. We know which are the prime numbers. The smallest prime is 2, then 3, then 5, then 7, then your 11, 13 and 17. He has said between 1 and 17, so we will take 17 also. Okay, so these are the numbers with which these options should be completely divisible. So let us have a blind guess. So obviously option number A and option number D are not divisible by 2. It can be easily seen that not divisible by 2 because they are odd numbers. So they cannot be the right answer because the right answer has to get divisible by all of them, but it is not getting divisible by 2, so they cannot be the right answer. Let us check for 510, 510 and 440, 440. If you check these numbers, see, look at the next prime number, that is 3. If you try to divide this number, that is 440, 440 by 3, it is not divisible, completely divisible. It is not there. There will be a remainder available. So clearly, option number C is also not divisible by 3. So the only number that is left out is option number B, option number B, which has the number as 510510. Okay, 51,510. That is the number. So obviously that is the only choice left out. So that should be the right answer only, option number B, which should be divisible by all the numbers, prime numbers between 1 to 17. Now, A is less than B, then which of the following numbers is greater than A and less than B? Okay, this is what is the question. Okay, so uh, if we want to know, see, he's saying A is less than B, so B is greater than A. So if you want to know any number between A and B, so any number between A and B is always the mean of those two numbers. So the mean is always calculated like an average. The mean is always calculated by A plus B by 2. That is the number exactly in between them. So that will be the number that will be between these numbers. Okay, which of the following numbers is greater than A and less than B? So that is he's looking for a number which is in between A and B, and that is the only way possible if you do A plus B by 2. So this is what is available in option number A, and directly becomes the right answer for us. Okay, when a number is divided by 45, it leaves the remainder 18. Find the remainder when the same number is divisible by 15, divided by 15. So if you remember the basic theorem of division is any number, okay, or we can call it as dividend, any number, or we can call it as dividend is equal to divisor into quotient, divisor into quotient plus remainder. Okay, this used to be the remainder theorem. Okay, any number or dividend is always divisor into quotient plus remainder. This is what we know. What he has said, when a number is divisible by 45, so the number is not given to us, so we'll assume the dividend as it is. Okay, dividend is divisible divided by 45, so the clearly the divisor is 45 into quotient he has not given, so we'll take quotient as q. So this is the first part plus remainder. How much he has got? He has got the remainder as 80. So this is that number he is talking about. The number is 45 into q plus 80. Okay, so obviously we will not be making the q's value possible, but what we'll assume that the complete number is 45 into q plus 18. This is the complete number itself. Now he says the same number is getting divisible by 15. So let us divide the name number by 15 and try to find out the remainder. Okay. So if you try to divide this in two terms, it can be divided like that: 45 into cube by 15 plus 18 by 15. This particular expression can be broken down as this way. Okay, if you cut it now 15 can completely cut 45. So obviously the remainder of the first term is going to be 0. Remainder of the first term of the division is 0. So ultimately the other remainder is important, which is 18 by 15. If you do 18 by 15, the remainder comes out to be 3. So the 3 will be the ultimate remainder of the number when it will be divisible by 15. So the right answer becomes remainder is 3, which is available in option number D. Okay, find the difference between 769 square and 768 square. Okay, so he's asking for the difference of 769 square minus 768 square. Obviously, in these type of questions, we're not gonna do the perfect square of this and perfect square of this. Rather, we'll try to use some particular formulas. What is that formula? If you try to match this condition with this a square minus b square, always the expression of this formula is a plus b, a minus b. So let us try to use this, a being 769 and b being 768. If you do that, this can be broken down as 769 plus 768 multiplied by 769 minus 768. Okay, and obviously 769 minus 768 is going to be 1. So 769 plus 768, that we need to add. Okay, and the total of 769 plus 768 is nothing but 1537, and 1537 into 1 we have to do, so that is going to be 1537 only. So clearly we didn't have to do any perfect square and then subtraction. We just did the addition and we could get the answer, which is 1537. Option available is option number C. Okay, now then he says find the value of x in 39 into 40 into 87 into 58 into 63 into 9x into 52 if the unit place digit of the given expression is 0. Okay, so let us take only the unit digits. Okay, the first number 39, the unit digit is 9. Second number unit digit is 0. Third number unit digit is 7. Then 8. Then 3. Then 9x. In this 9x, we don't know what is the unit digit. So let us skip this. Okay, let us skip this. Okay, we don't know the unit digit, and that's what we are supposed to actually find out. Okay, we are supposed to find out the x. So let us not take this particular thing. Okay, let us just clean it from here. Okay, we're not going to take this. We'll rather put a cap for this. Okay, because we don't know x, and the last number is 52. So the unit digit is 2. If you try to multiply these numbers together, there is a 0 available. So whatever be here, ultimately the unit digit of the whole expression is going to be 0. Okay, ultimately the unit digit of the whole expression is going to be 0. So whatever value the unit digit of this gap holds, whatever value it holds, ultimate unit digit is going to be 0 only, because there is a 0 available, and if you multiply anything by 0, it already becomes 0. So it doesn't matter what is going to be the unit digit of this gap, because ultimately the unit digit is becoming 0. So that means that this gap can take any unit digit. Okay, and how many unit digits are available? There are 10 unit digits available from 0 to 9. So the answer is can be any number between 0 to 9, which is available in option number E, and is the right answer. Okay, then it says number of times 99 is subtracted from 1111 so that the remainder is less than 99. Okay, we can again use the remainder theorem, which says the dividend is always going to be quotient into divisor plus remainder, quotient to divide divisor plus remainder. Okay, if you use this, okay, the number of times 99 is subtracted from 1111, so clearly 1111 is the dividend. 99 is subtracted, so that means 99 is continuously getting subtracted. See, division is nothing but the continuous subtraction. Okay, sequential and continuous subtraction is what is division. Sequential and continuous addition of the same number is actually multiplication. So if 99 is continuously getting subtracted, the 99 is actually dividing the number. Okay, so we need to divide this 1111 by 99. If we try to divide this 1111 by 99, 1111 by 99, we're going to get the divisor value as 11. That is 99 into 11. And how much is the remainder that we're going to get? We're going to get the remainder as 22. Okay, so we can understand that this particular number 1111 is not completely divisible by 99, but rather just if you subtract 22 from 1111, that is going to be your 1089. 1089 is completely divisible by 99. That means 22 needs to get subtracted from 1111, then only you can get the complete multiple of 99. And how many times you can subtract 99? You can subtract 99 11 times. If you subtract 99 11 times, then the last number you will be left out with 22, and obviously you will not be able to subtract 99 from 22. So clearly 11 times you can clearly subtract from 1111 the number called as 99. So that is the right answer. Option C, 99 is the right answer. Okay, so he says in dividing a number by 585, student applied the method of short division. He divided the number successfully by 5, 9 and 13, which are nothing but the factors of 585 only, and got the remainder of 4, 8 and 12 respectively. Okay. So when he would have divided the number by 5, he would have got the remainder as 4. When he would have divided the number by 9, he would have got the remainder 8 and 12 for the case of 13. If he had divided the number by 585, the remainder would have been. Okay, so for these type of questions, there is a special method. What we do is, there are three divisors that are available with us. First divisor is 5, then there is 9, then there is 13. The first thing we're going to do is we'll begin with the largest divisor, that is 13. Okay, and we'll assign some numbers, that is A, B and C consecutively, and the C will be dedicated to 13, 9 will be dedicated to B and 5 will be dedicated to A. Okay, so now and one more theorem that is going to be used is, that is the number or the dividend is divisor into quotient plus remainder. This is going to be used always. Now if you look at the divisors, okay, and the pattern between divisor and remainder, you can see when the divisor is 5, the remainder is 4. So the difference is 1. Again, when the divisor is 9, the remainder is 8. So again, the difference between divisor and remainder is 1. Divisor is 13 and remainder is 12. So the difference is again 1. So every time the difference between divisor and remainder is going to be 1. Okay. If you just add these two divisors, 9 plus 5 is 14. 14 minus 1 is going to be 13. So again, there is a 1 in the scene. So using this concept, the divisor minus remainder is 1 always, and using the largest divisor first, and using this particular theorem, we can write down C, which is the dedication of 13. C can be written as divisor is 13 into the difference of divisor and remainder is 1. So into 1 plus remainder. How much is the remainder that has been received when you have divided by 13? The remainder received is 12. So plus 12. If you make this number, this is going to be 13 plus 12, that is 25. Okay, so we're going to use C as 25. Now let's go for the B, and the divisor now is treated will be 9. Now again the same situation, divisor is 9 into, this time we'll use C as quotient plus remainder when the division was done by 9 was 8. So if you do this and use the value of C, that is 25, you have to do 9 into 25 plus 8, which is nothing but 25 into 9 is going to be 225 plus 8 is going to be 233. So this is the value of B. Now let us go to A. For the case of A, the divisor was 5 into, we're going to use the value of B here now, B plus the remainder for the case of 5 division was 4. So it's going to be 5B plus 4. B's value will be used as 233. So it's going to be 5 into 233 plus 4. If you add and multiply this, you're going to get the number as 1169. Okay, so the ultimate A value is coming out to be 1169, and our divisors have been finished. So after this, we take the next step. What is the next step? Now this 1169 can be made by, the ultimate division is done by 585. So the ultimate divisor is 585 into the quotient is 1 plus the remainder. Okay, plus the remainder that we have to find out. So clearly, if I try to divide 1169 by 585, I'm going to get the remainder value as, 584. So we can write it down here as 584. Okay, so that's what he was asking. When this particular number will be divided by the number will be divided by 585, what's going to be the remainder? So clearly the number we have found out as 1169, and when 1169 was divided by 585, we got the remainder as 584. So that is going to be the right answer. Remainder value is option number A, 584, and is going to be the right answer for us. Okay, compute the following: 7 plus 2 by 5 plus 3 by 4 plus 2 by. So we have to do it sequentially. We'll try to solve this part first and make it a fraction. Then we'll solve it with the 2 part also, and solve this denominator. Then we solve the upper denominator, and then we'll keep on moving towards upside. First denominator solve, second denominator solve, third denominator solve. Then we'll make some addition, and then we'll be able to solve this. So let us begin step by step. In the very first step, we're going to solve the very last denominator. So let us just copy the other number exactly as they are written: 5 plus 3 by 4 plus 2 by 3 plus 1 by 4. So we're going to have to solve this 3 plus 1 by 4 first, which is nothing but 4 to 12 plus 1, 13 by 4. So in the next step, what I can write as 7 plus 2 by 5 plus 3 by 4 plus 2 by 13 by 4. Okay, this is what we can write. Now we have to solve this 4 plus 2 by 13 by 4. In the next step, what we can write: 7 plus 2 by 5 plus 3 by 4 plus 2 divided by 13 by 4, that is nothing but 8 by 13. That is nothing but 8 by 13. Okay, now if you solve this, now we have to solve this 4 plus 8 by 13, and the result we'll write in the next step. So it's going to be 7 plus 2 divided by 5 plus 3 divided by 4 plus 8 by 13. 13 4 is 52 plus 8 is 60. So it's going to be 60 by 13. Okay, now we have to solve this particular thing. Okay, so it's going to be 13 will go up, so it will become 39 by 60. So in the next step, we can write down 7 plus 2 divided by 5 plus 39 by 60. Now we have to find out the complete solution of this: 5 plus 39 by 60. For this, we need to add 65 is 300. Okay, 300. uh, Rather we can cut this so that make it simple. Okay, we can cut this by 3. So it's going to be 3 13 is 39 and 3 20 60. So it has become 7 plus 2 by 5 plus 13 by 20. 20 into 5 is 100. 100 plus 13 is 113. So it's going to be 7 plus 2 divided by 113 divided by 20. If we solve this again, so this is going to be, let us do it here. Okay, let us do it here. So in the next step, it is going to be 7 plus 2 divided by 130 by 20 will be 40 by 113. If we take the LCM this time, 113 plus 7 into 7 plus 40, so it is ultimately coming out to be 831 by 113. 831 by 113. Okay, so that is going to be the final answer that is available in option number A. Now, a 4-digit number is formed by repeating 2-digit numbers such as 2525, 3232, etc. Any number of this form is exactly divisible by what? So what we're going to do, we will not use any particular method, rather we keep on watching the options, and we will keep on dividing the numbers given to us by options. Okay, whichever option is not being able to divide these numbers will be eliminated from our choice. So let us do it by 13. Okay, so if you try to divide number 2525 by 13, clearly it is not divisible. Okay, so obviously 13 is not going to be the right answer. If we divide the same number to 2525 by 11, 11 2 is 24, 1, 11 1 is 11, 115. So it is again not divisible by 11. So 11 is cannot also be the right answer. If you try to divide 2525 by 7, 7 4 3 is 21, 4 7 6 is 42, not divisible. So it is also not divisible by 7. So the only choice that we are left out with is smallest 3-digit prime number. What is the smallest 3-digit prime number? The smallest 3-digit prime number is nothing but 101. So this is what it will be the right answer, which will be able to divide all these numbers made in this particular fashion. So that is the right answer, option number D. Now he says, find the largest integer in the group of 3 consecutive integers if the sum of their square is 50. Okay, for these type of question, we choose the 3 consecutive integer in such a fashion so that when we add them, the numbers get easy to solve. Most of the numbers are get cancelled, as we do in arithmetic progression also. Okay, we have to choose 3 consecutive number such a way that when I try to add them, it becomes easy for me. So let me choose the three consecutive numbers. If they are consecutive numbers, they have to be in a gap of 1, x minus 1, x and x plus 1 I have chosen. Why I have done that? So that when I try to add them, the things become easy for me to solve. Okay. So if these are the three numbers that I have chosen, he says find the largest number in the group of three consecutive if the sum of their square is 50. So let us find out the sum of their squares. So the x minus 1 square plus x square plus x plus 1's whole square. Okay, this is the sum, and he says the sum of these square is 50. So let us equate this to 50. Now let us try to solve this. A minus b whole square is going to be a square plus b square minus 2ab, so minus 2x plus x square as it is, plus a plus b whole square is x square plus 1 square plus 2ab, that is 2x, is going to be 50. If you try to solve this further, what all things can get cancelled? Minus 2x can get cancelled with plus 2x. X square plus x square plus x square is going to be 3x square plus 1 plus 1, so this is going to be 2 is equal to 50, which gives me x square is equal to 48 by 3, that is nothing but 16, which gives me x value as 4. So x value has come. What he has asked for, find the largest integer. So largest number in this particular sequence is nothing but x plus 1. So that is 4 plus 1. The right answer is 5, which is available in option number A and becomes the right answer for me, 5. Now, if both 19 and 3 to power 6 are factors of the expression 36 square 7x 38 into 11 by 5, then find the smallest possible value of x. Okay. So, in these type of question, what we do? We try to do the prime factorization. We do the prime factorization of the expression, and then we check that how much far we are from the real prime factors. Okay. So, let us do the prime factorization first. Okay. If you do the prime factorization, this 36 square into 7x into 38 into 11 to the power 5, we have to do the prime factorization. 36 square, if you do the factorization, is going to be, see, we can do it here. 36 square is nothing but 6 to the power 4, and 6 to the power 4 can be written as 2 to the power 4 into 2 to the power 4. So this is the prime factorization of 36 square. So in place of the 36 square, we're going to write 3 to the power 4, 2 to the power 4 into 7x. We cannot do the prime factorization. We can rather write 7 to the power 1 into x. Okay, we don't know the power of x, into 38 can be broken down as 19 into 2. 19 itself is a prime number, into 2 to the power 1. 11 is itself a prime number, so 11 to the power 5. This is the prime factorization. Now we have the common number, that is 2 and 2, so we can add the power. When the numbers get multiplied, the powers get added up. So it's going to be 2 to the power 4 into 2 to the power 4, rather 2 to the power 5. 2 to the power 4 into 2 to the power 5 into 7 is as it is, into x as it is, into 19 and into 11 to the power 5. This is what we have got. Now, if you clearly see it, he says 36, 19 and 3 to the power 6 are the factors. So 19 is as it is available. So there is nothing to be added up. There is no more power of 19 to be added up. Then the next thing he said is 3 to the power 6. 3 to the power 6 is a factor. That means we just have 3 to the power 4. The maximum power of 3 is available with us is 4. But he says 3 to the power 6 is the factor. That means 2 powers of 3 is missing. So that means the number that will complete the complete expression of this will be 3 squares, and that should be the x value. Okay, so the ultimate x value is 3 square, that will complete the expression, and all the factors will be available. So the 3 square is going to be 9. So the right answer is 9. It is not available in any of the options, so we have to take option E, and the right answer is 9. Now, the next is sum of number and its reciprocal is thrice the difference of the number and its reciprocal. Find the number. For these kind of question, we first of all assume the number, okay, and then we try to formulate the terms given to us into an expression, into the equation, and we try to solve the equation. Okay, so the first and foremost thing what we do, let the number be x. Okay, the first condition he has said sum of number and its reciprocal. So if the number is x, the reciprocal of x is going to be what? Reciprocal is nothing but multiplicative inverse, that is 1 by x. So this is the number, this is the reciprocal. He has said sum of these numbers. So what is going to be the sum? It's going to be x plus 1 by x. This is going to be the sum. He says this sum is thrice the difference of the number and its reciprocal. So let us try to find out the difference. Okay, the difference is going to be x minus 1 upon x. Then he says the sum is thrice of the difference. The condition that is given to us is sum is thrice the difference. Thrice the difference means 3 times the difference. So if we use this, we can write x plus 1 upon x in place of sum is equal to 3 times x minus 1 upon x. Okay. So we have to make an equation out of it. If we try to solve this, this is going to be x square plus 1 over x is equal to 3x square minus 1 over x. So 3x square minus 3 over x. This x and x get cancelled from both the sides. So we are left out with x square plus 1 is equal to 3x square minus 3 if we try to solve this. So 3x square minus x square is going to be 2x square on the right hand side, and 1 plus 3 is going to be 4. If we solve this, x square is coming out to be 2. So clearly the value of x is root 2. Okay, clearly the value of x is root 2, which is available in option number A and becomes the right answer for us. Okay, think of a number divided by 9 and add 9 to it. If the result is 27, the number is okay. So he has said us to think the number. We'll think the number. Let the number that we think is x. We'll again try to frame the conditions and try to make an expression out of it, the equation out of it, and then to try to solve the equation. So let the number is x. He said divided by 9. So let us do it. X by 9. And then he says add 9 to it. So I have added 9 to it. So this is what he's saying, the result is going to be 27. So we have made equation out of it. If we try to solve this, 9 being the LCM, x plus 9 9 81 is equal to 27. So we can write down here as x plus 81 is equal to 27 into 9. That is 9 7 is 63, 3 6, 9 2 is 18 and 6, 243. So x is going to be 243 minus 81, that is nothing but 162. That's what he had asked for. The number is 162 in option number D. Now, the prime numbers between 1 to 100 are, how many prime numbers are there? So we can anytime find out the prime numbers, but it will be good if we can remember them. Then obviously cannot be any trick here, because the prime number are never in a particular pattern. Okay, they are randomly distributed over the natural numbers. So there cannot be a particular formula for finding out this. We just have to catch them. Okay, one by one. The smallest prime number is 2, 3, then we have 5, then we have 7, then we have 11, then we have 13, then we have 17, 19, 23, then we have 29, 31, 37, then there is no number in 30s, then it has to be 41, 43 is a prime number, 47 is a prime number, then there is 53, 59 is prime number, 61, 67, 71, yes, 73. Prime numbers are the numbers which are not divisible by any other number except 1 and they themselves. Okay, no one can divide them except 1, which because 1 can divide everything, and they themselves. Okay, so they are the numbers 83, 89, 97. So if you count them, they are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they are coming out to be 25 in number. So between 1 to 100, there are 25 such numbers which are prime numbers. So answer is option number C. Now, the product of two prime number is a. Okay, so let us try to have an example and then try to find out. Let us have 2 and 3. They are the smallest two prime numbers. Product of 2. So 2 into 3 is going to be 6. Okay, so it can be an even number. Let us take one more example, 3 and 5 together, but 5 into 3 is making it 50. So obviously they cannot be even, they cannot be odd. Sometimes they can be even, sometimes they can be odd. So that's what should be the answer, either odd or an even number. Okay, so that becomes the right answer for us, either odd or even number, option number C. Now, find the total number of divisor of the number 6 to the power 5 into 7 to the power 6 into 11 to the power 10. So for this particular situation, we have a method. What is that method? For any number that has a factors, prime factors as a to the power p into b to the power q into c to the power r. If any number can be distributed into its prime factor like this, then the number of factors, total number of factors of such number can be p plus 1 multiplied by q plus 1 multiplied by r plus 1. These can be the total and so on. Okay, as many you can break down them into. So we are just supposed to break this particular expression into the basic prime factors and their powers. Okay, so this is what is the expression, 6 to the power 5 into 7 to the power 6 into 11 to the power 10.
6 is obviously not a prime number, so we will have to break this. This is going to be 2 into 3. 2 to the power 5 into 2 to the power 5 into 7 to the power 6 into 11 power 10. Now, so we have got our A, we have got B, C, and D. So we can use this formula P plus 1, Q plus 1, R plus 1, and in the product. So P is going to be 5, Q is also 5, C is 6, and D is 10. So if you add them, it's going to be 6 into 6 into 7 into 11. So we are just supposed to product this. If you do the product out of them, you are going to get 2772, 2772 as the result. So that is what is going to be the right answer. Option number D, 2772 is the right answer. Now, the greatest number by which the product of three consecutive multiples of 3 is always divisible is. In this type of situations, we first try to make the numbers, and as he has asked for the consecutive numbers, so we have to take care of that completely. Okay, the greatest number by which the product of three consecutive multiple of 3. So any number that is multiple of 3, the smallest can be 3n, where n being any natural number. The next consecutive number will be 3 times n plus 1. Okay, and the next consecutive number will be 3 times n plus 2. Okay, so these are those three consecutive number which are multiple of 3 also. He says greatest number by which the product of three consecutive, so we need to find out the product of them. So let us try to multiply them. 3n plus 3 multiplied by 3n plus 6. If you try to multiply 3 3 are 9, 3 are 27 n cube into 27 n cube has come uh, multiplied by 81 n square plus, if you multiply, it's going to be 54n. I've just done the product of these three numbers. This is what I'm getting. Obviously, I can take maximum 27 as common. If I take the max 27, and yes, n can be also taken common. So in the first term, I am left out with n square. In the second term, I am left out with 3n, and then last term we am left out with 2. So this is what is 27 is out of it. So he says greatest number by which the product of, what is that greatest number which can divide all of them. Okay, so let us take the very small example of the smallest natural number 1. If we take the smallest natural number of 1, so let us put n equal to 1. If you put n equal to 1 for the case of smallest three triplet of any three consecutive number that are multiple of 3, so for that, if you want the smallest triplet, you have to put n equal to 1. If you put n equal to 1, it's going to be 27 into 1, 1 square plus 3 into 1 plus 2, which is going to be 27 into 3 plus 2 is 5 plus 1, 6. That is nothing but 162. So clearly, the smallest triplet even also can be divisible by 162. So that should be the right answer only. So 162 is the greatest number which can be divisible by three consecutive natural multiple numbers. Okay, so that is the right answer, 162. Now, if x and y are both odd numbers, which of the following numbers must be an even number? If x and y are odd numbers, which of the following must be an even number? Let us try to do it by some example. Let us have two odd numbers, 3 and 5. Okay, let us try to fix the option number A. 3 plus 5 is going to be 8. Okay, let us give one more example. Any other combination of odd number that have 7 and there has not said natural. So we'll assume any other number. 7 plus 11 if you do, that is going to be 18. So every time if you add two odd numbers, you're going to get the even number as the sum. So that's what should be the answer. Option number A, x plus y. Now find the total number of odd numbers up to 361. Okay, total number of odd number up to 361. For this case, there is a smallest number, there is a smallest method n plus 1 by 2. Okay, where n being the odd number that you are looking for. How many odd numbers are there from 0 to 361? For finding out that, just use this formula n plus 1 by 2, where n being the 361 only. So if you do this, 361 plus 1 by 2, you're going to get to you're going to get to 362 by 2, that is nothing but 181. So obviously, how many odd numbers are there from 0 to 361? Answer is going to be 181, which is available in option number B, becomes the right answer for us. Now, what should be added to the product of four consecutive odd numbers to make it a perfect square? How much should I add to the product of four consecutive odd numbers? So let us try to make the consecutive odd numbers. We'll try to make the consecutive odd number in such a way so that it is easy for us to solve them. I will not try to take the bigger numbers. I'll try to make the lesser number. For that case, I can use the negative things also. The negative numbers can also be taken into account so that the things get cancelled as much as possible. So let us try to first assume the four consecutive odd numbers. Okay, let me take 2x minus 3 as my first odd number. See, if you put any number in place of x, you're going to get the odd number only. Look at that. If you put x equal to 1, you're going to get 2 into 1 minus 3. That is going to be minus 1. That is again odd number. If you put x equal to 2, you're going to get 2 to the 4 minus 3. That is 1. That is again odd number. If you put x equal to 3, you're going to get 2 3 the 6 minus 3. That is again odd number. So this is what is the standard form: 2n minus 1 or 2n minus 2 or 2n minus 3, anything. Okay. So this is the first odd number he had said for consecutive. So the next consecutive will be 2x minus 1. Okay, the difference of 2 should be there between odd numbers. So that's why the difference of 2 has been created. The next odd number will be again the difference of 2. So there will be 2x plus 1. Okay, and the last odd number that we will take is 2x plus 3. Okay, we have taken this into account so that when the things get added up, most of the numbers are cancelled. Okay, now these are the four consecutive odd number that we have taken. He had asked us to what should be added to the product. So we need to do the product of them. That means we need to multiply them. If we try to multiply them, what do we get? Okay, 2x, 2x, 2x and 2x. 2x is getting multiplied 4 times. So we can use one more thing here. If you see the pattern, this is 2x minus 3 and 2x plus 3 being done in a product form. We know that a minus b and a plus b, if we do the product, we get always a square minus b square. So if 2x minus 3 and 2x plus 3 will be formed in a product form, they can be written as 2x whole square a square minus 3 whole square b square. Similarly, the other pair 2x minus 1, 2x plus 1, a minus b, a plus b, so can be written as a square, that is 2x square, minus b square, that is 1 square. Okay, and again these are in the product form. If you can see, they are again in the product form. So how much it is becoming? This is becoming 4x square minus 9, and the other product is becoming 4x square minus 1. These are the two products that we are having. Okay, now let us try to multiply them all together. So it's going to be 16x power 4 minus 40x square plus 9. This is the ultimate product of all those both the terms. Okay, now he said what should be added to this. The question is how much should I add to this thing so that it becomes a perfect square. So I'll have to find out how much away it is from becoming a perfect square. For that, I need to break this down again. So if we try to break this down again, I can break this down as 4x square minus 5 whole square minus 16. Okay, this can be broken down like this: 4x square minus 5 ka whole is 5 whole square minus 16. So clearly, this first term is a perfect square, and this second term is a perfect square, but they are in a subtraction form. So when they are in a subtraction form, they cannot be a perfect square. But if the 16 is eliminated from this particular expression, if 16 is eliminated, this number will be just left out as 4x square minus 5 whole square, which will be nothing but a perfect square itself. So how much should I add to this expression? I just need to add plus 16. If I add plus 16, this 16 will get cancelled out, and I will only be left out with the already available perfect square. So the right answer is how much should I add to this expression? I should add 16 to this expression to give me a perfect square, and that is available in option number B and becomes the right answer for us. Okay. Which one of the following has maximum number of divisors? Okay. Which of the following number has maximum number of divisors? Okay. Before doing that, we need to recall this fact that the prime numbers are the only numbers which don't have any divisor. Prime number don't have any divisor, except no prime numbers have no divisors. Let us write like this: no divisors except 1 and itself. That means they have just two divisors, that is 1 and itself. So we can check it like that also, because it will be very difficult otherwise to find out the divisor of all the number and then check which is having the highest divisor. So we'll rather check for the prime number out of them. Okay, because the prime number has got the least divisors. So let us check 133. 133 is a prime number because 133 is only uh, rather 421. We'll check for this one by one. Okay, we'll check for 133 first. 133 is not a prime number, because if you try to divide 133, you can divide 133 by 7. Okay, if you divide it by 7, that is going to be 7 1 is 7, is going to be 6. So 7 1 is 7, and then it's going to be 6. So 7 9 is 63. So it can be divided by 19 also. 7 also and 19 also it can be divided by. So it has got two factors, 7 and 19, and obviously 1 and itself is already available. So 133 has got four divisors. Okay, 1, 133, 7 and 19. Four divisor it has got. Let us talk about the other numbers. Okay, the other numbers are 383, 421, 1249 and 1867. If you check it thoroughly, all these numbers are complete prime numbers. The prime numbers can be checked by dividing it by 2, 3, 5, 7, 11 and 13 and so on. So only the 133 is not a prime number. So if it is not a prime number, then it will clearly have more divisors than the prime number. So that what was the question, which one of the following has the maximum number of divisors? Answer is 133, option number A. Next, a number x when multiplied by 5 and added to 3 times its own gives 64. The number is. For these type of question, as done in the earlier questions also, we try to do what? We try to do assume the number first and try to apply the condition. Whatever condition has been given to us, we try to apply those condition into it and then try to equate it to the right hand side and then solve that equation. Here he has already given us the number x, so we don't need to assume it. A number x when multiplied by 5. Okay, so number x is multiplied by 5, so let us do it 5x by 5 and added to 3 times its own. So it has to get added to, let's have a plus sign, 3 times its own, so that is 3x. 3 times its own is 3x. He said it gives the result as 64, so it is going to be 64. Okay, if you add them, it is going to be 8x is equal to 64. If you solve this, x is going to be 64 by 8, which is nothing but 8 itself. So the value has already come. The x value is coming out to be 8. That is available in option number A and becomes the right answer for us. Okay, he says in a group of 10 consecutive numbers, if the sum of the first 5 number is 30, then find the sum of the last 5 numbers. So what we'll try to do, we'll not try to take all those 10 numbers to all together, but we'll rely to the condition given to us, that is sum of first 5 number is 30. So let us take any sum of first 5 numbers. Okay, you can start with x, x plus 1, x plus 2, x plus 3 also. Okay, or either you can begin like this, x minus 2, x plus 1. What we are doing, we are assuming the first 5 numbers, okay, consecutive numbers. So there has to be in a gap of 1 1. So x minus 2, x plus 1, another should be x, then has to be x, rather this has to be x minus 2, x minus 1, x, x plus 1, and the last number should be x plus 2, like that. These are the 5 consecutive numbers. He says sum of these 5 numbers is 30. So let us try to add them. If you add them together, he says the sum should be 30. So there is the advantage of taking negative numbers. The numbers get reduced up. So if you add them together, you are left out with 5x is equal to 30, which gives us x value as 6. As I have got the x value as 6, now I can easily find out the sum of the last 5 numbers. For doing that, I'll have to first fix the last 5 numbers. The next number, that is after x plus 2, will be x plus 3, then will be x plus 4, and so on. We have to find out 5 numbers. So this has to be 3 4 5 6, 3 4 5 6 7 should be the last number. So using x axis, x as 6, we can find out the number. It will be 9, then it will be 10, so next will be 11, next will be 12, and next will be 13. So if you add them together, it's going to be 19 plus 11 is 30, plus 12 is 42, plus 13 is going to be 55. That's what he has asked for. Sum of the last 5 number, and answer is 55, available in option number C. Now, the largest number, which is a factor of 56 as well 84. So there's a thing called as largest number, which is a factor of 556 as well 84 is. There's a thing called as highest common factor. Highest common factor. This is what is the thing called as highest common factor. That's what they are also indicating. Highest indicates largest factor of both 56 as well 86. So obviously it has to be common. okay, as well as factor. So we are supposed to simply find out the highest common factor of 56 and 84. Okay, so 56 and 84, for that we need to do the prime factorization. If you do the factorization of 56, is going to be 228, 2 then 14, 2 then 7. So it is 56 can be written as 2 cube into 7. Now let us try to do the factors of 84. If you do it, 2 with 42, 2 with 21, 3, 7 ja. So it is 84 can be written as 2 square into 3. So these are the prime factors. We have to find out the highest out of them. So commonly highest is 2 square. Okay, 2 square is available in both the things. Okay, this is how we can find out the highest common factor. 2 has divided 56 by 28. Then uh, 2 has divided 14, 2 has divided 7, so 2 cube into 7. And the next thing that we did was for 84, that we did 242, 221, and then there should be 3 7 ja 21. So there has to be 7 also written here. The 7 was missed out. 2 square into 3 into 7. So the highest common factor is 2 square, and a 7 is also available. So the HCF is 2 square into 7. That is nothing but 28. So that is the highest common factor and is our answer also. Now he says find the sum of all odd numbers between 40 and 50. Okay, because the range is very small, so we can manually add them also. Otherwise, will have to use the formula. Okay, because here the range is very small, so let us simply add them together. The first is 41, then it will be 43, then it will be 45, then it will be 47, and the last odd number in such fashion will be 49. If you add them together, simply the sum is coming out to be 225, and that should be the right answer only. The sum of all the odd numbers between 40 and 50 is going to be 225, and that is the answer available in option number B. Now find the smallest perfect square which is divisible by 15, 7 and 21. We have to find out the smallest perfect square which is divisible by 15, 7 and 21. So first of all we need to do the factors of 15, 7 and 21, and from the factors we can understand that how much should be added or how much should be multiplied so that the number should become the perfect square. Okay, so what is that? The prime factor of 15 is 3 into 5. The factors of 21 is going to be 3 into 7. The factors of 7 is just 7. Okay, so these are the factors of the number that we are looking for. Okay, the number that has to be get divisible by all three, these should be the factors of that number. Here if you see it carefully, 3 has been used twice, so 3 square. 5 has been 7 has been used twice, so 7 square into 5's power is just 1. But a number that has a perfect square always has all the powers of 2. All the factors should contain the power of 2. In this case, the number 3 has got a power of 2, number 7 has got a power of 2, but number 5 has not got a power of 2. Okay, so clearly there has to be 5. If 5 one more 5 is taken together, then we'll have a power of 2 as well. So the perfect square should contain the power of 2 of 3, 5, 7 both. So the next number that is to be multiplied so that the number becomes perfect square should be 105. So clearly if you add one more 5 to the power 1, then the number can become perfect square because the 5 will also have power as 2. So how much is this particular number? If we have 5 square also, it's going to be 9 into 49 into 25. If you multiply them together, this is coming out to be 11025. That is 11,025 is the number, and that is available in option number A, and is a perfect square also, and is get divisible by all these numbers also. Now he says find the unit digit of 8 to the power 204 and 6 to the power 204. Okay, so let us try to do it. For this case we need to know the cyclicity of 8. Okay, cyclicity of 8, that is the cyclicity is nothing but the last digit or the unit digit of the 8's power. So if you do the 8 to power 1, you receive 8. If you do 8 square, you receive 64. If you do 8 cube, the last digit is 2. If you do 8 power 4, the last digit is 6. Then if you do 8 to power 5, the last digit is again 8. So there is a pattern of 8 4 2 6, then again 8 4 2 6. So we can understand that after every fourth power, the last digit repeats of 8. So the cyclicity of 8 is nothing but 4. The numbers are 8 4 2 and 6. Let us check the cyclicity of 6. If you keep on increasing the power of 6, you get the numbers as 6 square is 36, 6 cube is 216, and so on. So if you see the pattern, every time the last digit of the powers of 6 increased is just 6. So cyclicity of 6 is nothing but 6 only. That is, every power of 6 has got a last digit of 6 only. Okay. So if we use this concept, we don't have to get the power of 8 to power 204 and 6 to power 204. Rather, we can say the last digit of 8 to power 204 will be, okay, let us try to divide the 204 by the cyclicity of 8, that is 4. If you do this, this can be written as 4 into 50 into 8 to the power 4. This is how we can divide this as 8, 450 into 4 into 8 to the power 4. Here, the last digit of this particular expression, this has got 4th power. So last digit will be 8426, that is 6, into 8 to the power 4. 8 to the power 4 has got a last digit of again a 6. So 6 into 6, 36. The last digit comes out to be 6 itself. If you see the 6 to the power 204, 6, the number 6 has got every power. If you increase any power of 6, the last digit of the expression is answer going to be 6 only. So last digit of 6 to the power 204 is also be 6. So ultimately you are getting 6 minus 6, that is 0. So the last digit or the unit digit of the whole expression is nothing but the difference of their unit digits, that is coming out to be 0. So the ultimate answer for this question is option number B,